Hi! Today we're going to take a look at section 7.5, which are the double angle and half angle formulas. So this is just a bunch of formulas that you will be given. Okay, you don't have to memorize these. And what they are, imagine that I know things about some angle theta. Okay, I know the sine of theta, the cosine of theta, whatever. I know everything there is to know about this angle theta. With these formulas, I now know the sine, the cosine, the tangent of an angle that's exactly twice the size of that. So if I know everything there is to know about theta, I now know everything there is to know about an angle that's twice as big as theta. I'm also going to know everything there is, the sine, the cosine, the tangent, of an angle that's half the size of theta. So that's what these formulas do. Given an angle, I now know everything about an angle twice as big as that angle and an angle that's half the size of that angle using these formulas right here. Okay, the double angle formulas you're going to have a pretty easy time with. The sine of 2 theta is just 2 times the sine of theta, cosine of theta. There are 3 different cosine formulas. It does not matter what you use. Cosine squared minus sine squared. So if you know the cosine and the sine, you could plug both of those values in and then square them and subtract them from each other. If you knew the sine of an angle and only the sine, then you could use this formula. It's 1 minus 2 times the sine squared. So take the sine of the angle, square it, then take that times 2, and then 1 minus that answer. If you knew the cosine of the angle, you could do this. I am going to tell you this one is usually the easiest because the sine and the cosine are going to be fractions. And when you square them both, you're going to get these 2 fractions with common denominators, so you're going to be able to simplify easier. That's just what I found, that this is the easier of the formulas to use. Okay, and then this is the double angle formula for tangent. Okay, it's 2 times the tangent of the angle. Again, this is the original angle theta that we know things about, and then that's going to tell us the tangent of an angle twice that size. Okay, the half angle formulas. So the formulas over here, they're using alpha instead of theta, but it's the same thing, okay? I'm going to know something about some angle alpha, and now I know the sine of an angle that's half the size of that angle alpha, or theta, whatever, okay? So here are the formulas. It's plus or minus the square root of 1 minus cosine divided by 2. That's the sine formula. The cosine is plus or minus radical, and then it's 1 plus the cosine. So these are the same, it's just this is 1 minus and this is 1 plus. And then you've got 3 different versions of a tangent formula that you could use. Now, here's the problem with the half angle formulas. This plus minus symbol, this is not something you are going to write. You are not going to write a plus minus symbol. You're going to make it positive or you're going to make it negative. This is a decision that you're going to have to make. And that decision is going to be based on where is this half angle. Okay? If I have some angle that is in, quadrant 2, the original angle is in quadrant 2, what quadrant would exactly half of that angle be in? And then you are going to make that positive or negative based on your all students take calculus and whether or not that should be positive or negative. So again, some quick things. If they tell you that the original angle is in quadrant 1, okay? The angle A is between 0 and pi over 2. That's the fancy way of saying that it's in quadrant 1. Well, where would an angle that's exactly half the size of that be? Well, when they tell you that this angle is between 0 and pi over 2, they're not telling you what the angle is. They're just telling you some boundaries, okay? Your angle is somewhere between 0 and pi over 2. It's somewhere in quadrant 1. Well, if you divide this angle in 2, it's also going to divide these 2 boundaries in 2. Okay? It's not going to be, your angle, this half angle is not between 0 and pi over 2 anymore. It's between 0, because 0 divided by 2, and pi over 2 divided by 2. It's going to cut these boundaries in half. So that's pi over 4. Okay? Well, think about it. Think about it in degrees. It'll make your life easier. If the original angle is somewhere between 0 and 90, and you're going to cut that in half, then this new angle is somewhere between 0 and 45. Okay, it's exactly half of those. So if your original angle is in quadrant 1, your half angle is also in quadrant 1. So if I was trying to find the sine of the half angle or the cosine of the half angle, I'm going to use the positive version because I know that sine and cosine are positive in quadrant 1. Okay, so I'm not going to put a negative in front of my radical. I'm just going to leave it positive. What if they gave you this? What if the original angle was between pi, so think where that is, and 3 pi over 2? Okay, so my original angle is in quadrant 3. So where would its half angle be? Okay, so let's think about this. This is your original angle. These are the boundaries. It's somewhere between here. If we are going to take this angle and cut it in half, it's also going to cut those boundaries in half. So take pi and cut it in half. That's pi over 2. Take 3 pi over 2 and cut it in half. That's 3 pi over 4. Okay, so visualize this. Where's pi over 2? It's right here. Where's 3 pi over 4? It's right here. Here's 3 pi over 4. So this half angle would be somewhere here. It's in kind of that upper section of quadrant 2. But the only thing we need to know is that it's in quadrant 2. It's somewhere in quadrant 2. The half angle is. So now, if I'm trying to find the sine of this half angle, because the half angle is in quadrant 2, I'm going to leave it positive. If I'm trying to find the cosine of this half angle, I'm going to make it negative because cosine is negative in quadrant 2. Now for tangent, there's 3 different formulas. This one tells you have to make a decision about whether it's plus or minus. These 2 formulas you don't have to make a decision. Okay? The decision it'll just come out the way it's supposed to. If you plug in the cosine of A, the sine of A, you subtract, you simplify your fraction, this answer, if you were doing this one, you would get a negative answer. The answer would simplify to give you a negative just like you want. So don't use this one. Okay? You're never going to want to use that one. These 2 will take care of it all on their own. And I have found that this is the easier one to use. It has to do with the fact that you're dividing by a fraction instead of dividing by like an addition problem that probably will have a fraction in it. This one's just easier to use. Okay, so that's my advice when it comes to using these. Now that I've explained all of that, let's take a look at this. First, we're going to look at the double angle formulas, and like I said, you're probably going to find this to be pretty easy. Okay, if the tangent of theta, so here's the original angle theta that we're going to base our information that's going to get plugged into these formulas. Okay. The tangent of theta is 1 over 2, so we know the opposite and the adjacent of this angle, which means that we can also find the hypotenuse. We're just going to have to draw a picture. Now, again, they're not using the inverse notation. They're just telling us that the tangent of this angle is 1 over 2, so they have to also tell us where this angle is. So this angle is between pi and 3 pi over 2, which is in quadrant 3. So that makes sense. Tangent is positive in quadrant 3, so that's a place it could be. The opposite and the adjacent are 1 and 2. Now, do not put a 1 and a 2. That's wrong. If you're in quadrant 3, that's a -1 and a -2. But they cancel each other out, and so we didn't see them over there. Okay? So, this is our triangle, -1 and -2. That means our hypotenuse is radical 5. That squared plus that squared is 5, so radical 5. Now, I know everything there is to know about theta. I know the sine of theta. It's -1 over radical 5. That can be rationalized. I know the cosine of theta, -2 over radical 5. I know the tangent of theta, -1 over -2. I know everything there is about theta, and that's what I'm going to plug in to the formula to find the sine of an angle that's exactly twice as big as theta. So the formula for the double angle formula for sine is 2 times the sine of theta cosine of theta, which is 2 times, well, what's the sine of theta? -1 over radical 5, which we would rationalize, but I'm not going to. I'll show you why. Times the cosine of theta. Well, that's -2 over radical 5. And now I have something times something times something. I just got 3 things multiplied together. So multiply straight across. These are fractions. Think of that as 2 over 1. Multiply straight across. These 2 negatives are going to cancel each other out. 2 times 1 times 2 is 4. These 2 radicals are going to cancel each other out. Radical 5 times radical 5 is just 5. That's your answer. That's it. That's all we're doing. Okay? Look at the next one, the cosine of 2 theta. So the double angle formula for cosine. Again, this is the easier one to use. The cosine squared of theta minus the sine squared of theta. So what do you need? You need to know, I'm going to go ahead and write that down, cosine squared theta minus sine squared theta. Now what this means is, take the cosine of theta and square it. Okay? In our brain, it seems like it would be better if they wrote this. Cosine theta squared. But they don't. That's not how it's written. Okay? So this is how you write it, but this is what it means. Take the cosine of theta, which is negative 2 over radical 5, and square that answer. Okay? Minus the sine squared of theta. So take the sine, so negative 1 over radical 5, and square it. But then watch what's going to happen. Remember, when you square a fraction, it's the numerator times itself and the denominator times itself. So negative 2 squared, that's 4. Radical 5 squared, that's 5. Minus negative 1 squared is 1. Radical 5 squared is 5. So the entire problem is just 4/5 minus 1/5, which is 3/5. That's your answer. Okay? All right, last one. Tangent of 2 theta. So here's the tangent formula. It's 2 times the tangent of theta. So 2 times, what's the tangent of our theta? Well, it's 1/2. 2 times 1/2 over 1 minus the tangent squared. So 1/2 squared. All right, so let's simplify. Let's figure out what's going on here. Let's simplify the numerator. 2 times 1/2. Well, that's 1. Okay. 1 minus 1/2 squared. Well, 1/2 squared is 1/4. 1 minus 1/4 would be 3/4. And then 1 over 3/4 is the same as 1 times 4/3. So 4/3. That is your answer. That is the tangent of an angle that's exactly twice as big as this angle. Okay? That's the cosine of an angle that's twice as big as that angle, and that's the sine. Okay? All right, now on the back, we're going to take a look at the half angle formulas. Okay? So again, the first thing they're going to do is they're going to tell you something about a given angle. So in this case, they're using alpha. We could have used theta. It doesn't really matter. Okay, so if the tangent of alpha is 4/3, and they're also telling us where alpha is, that it's between pi and 3 pi over 2. So let's use that information. So this is in quadrant 3. So we're somewhere here. We know the opposite and the adjacent, so 4 and 3, but both of those should be negative. Okay, so that's a negative and that's a negative since we're in quadrant 3. I'm going to go ahead and label my A there, that's alpha. And then the Pythagorean theorem, this is a 3, 4, 5 triangle, so we're good to go. So that's everything I would need to know about alpha. Now, down here they're going to ask us, you know, what is the sine of half of alpha, or the cosine of half of alpha, or the tangent. So we have to understand where that is. If an angle is in quadrant 3, if a given angle is in quadrant 3, so if it's between pi and 3 pi over 2, then its half angle is going to be between pi over 2 and 3 pi over 4, which is, again, if you visualize that, here's pi over 2, here's 3 pi over 4. It's somewhere here. It's in this like upper section of quadrant 2. Okay, so that is what we need to remember. As we're doing these problems, this half angle that we're looking at is in quadrant 2. So when I find the sine of this angle, I am going to use the positive version of the formula. Okay, if you look on if you flip your notes, on the other side, the formula for the half angle is, it's the square root of 1 minus the cosine of alpha, the original alpha, divided by 2. Now, if I so there's only one thing to plug in, the cosine of alpha. Okay, so that's going to be the square root of 1 minus The cosine of that angle is -3/5. So this will be +3/5, if you'll allow me to go ahead and let the two negatives cancel, over 2. Now, that is ugly, okay? I've got a fraction inside of this fraction, and we're under a radical. So first thing I want to do is I want to clear these fractions. I do not like this. So what I'm going to do is I'm going to multiply everything by 5. Okay, this is the magic number. I'm going to multiply the top by 5. I'm going to multiply the bottom by 5 because 5 over 5 is 1. So I'm not really doing anything. I'm just changing the way it looks. And so what I'm going to get is, let me come over here. So it's still going to be the square root. That hasn't changed. So it's 5 times 1. It's 5 times 3/5. So that's just 3. And it's 5 times 2. So that's 10. Okay, so let's see what that gives us. 5 plus 3 is 8, 8/10, which would reduce to 4/5. Now, the square root of 4/5, when you're doing the square root, it's the square root of the top divided by the square root of the bottom. You can separate it into two different radicals. And since our numerator is a perfect square, we can take the square root of both of these and get 2 over, now the 5 is still under a radical, but now this can be rationalized. I can move the radical 5 up, 2 radical 5 over 5, and that is the final answer to that problem. Okay, there's a lot of reducing, a lot of little baby steps. None of those steps was very hard, but when you put a whole bunch of them together, it looks like there's a lot going on there. Okay, so that's the sine of the angle that's exactly half the size of the angle they gave us. Now, example B is cosine. So a couple things. First off, we need the negative version of this one. Okay, cosine is negative in quadrant 2, and since this half angle is in quadrant 2, we need to use the negative. Still square root, but this is 1 plus the cosine of alpha over 2. So this one will be negative 1 plus, well, what is it? It's 1 plus -3/5. So we could just leave this as -3/5 over 2. Everything's under that radical sign. Again, I could multiply everything by 5, giving me negative radical 5 minus 3 over 10, negative 5 minus 3 is 2, and if you will allow me to take 2/10 and go ahead and reduce it to 1/5. Again, 1's a perfect square, so I can take the square root of the numerator. That's going to be 1 over radical 5, and I get my final answer of negative radical 5 over 5. Now, notice that somehow I didn't lose my negative sign. That's an easy mistake. We write it down here, and then with each of these steps, we have to keep bringing the negative along and make sure we don't lose it and turn our answer positive accidentally. Okay, that's usually the main issue that happens on these. Okay, but that's your final answer. Now, the tangent. Remember, the tangent formula that I told you is the easiest to use is this one. 1 minus the cosine of alpha over the sine of alpha. So this one's going to involve two plugins. Okay, 1 minus the cosine of alpha is -3/5, so this will be +3/5, over the sine of alpha, which will be -4/5. Again, there's a couple ways to handle this. I like to just clear my fractions first. Okay, I'm going to multiply everything by 5. It's going to give me a 5 out front, but then this is going to turn into just a 3, and this is going to turn into just a -4. And so literally all I have is 5 plus 3, which is 8, divided by -4 is -2, and that is done. That's your answer. Okay, so those are the half angle formulas. All right, now on the bottom here, it says find the exact values using the half angle formulas. Okay, so they would like to know what is the cosine of pi over 8 and what is the tangent of 165. Now, what they're saying, by saying use the half angle formulas, what they're saying is this angle is half of something that we are more familiar with, okay? Something that's like on our chart. For example, pi over 8 would be half
of pi over 2. If you took, or excuse me, pi over 4. If you took pi over 4 and cut it in half, you would get pi over 8. So this is the half angle of that. So if you treat pi over 4, think of that as the alpha in the formulas, or the theta, okay, then this is half of that. So to find the cosine of pi over 8, I just need to do this. I need to use the half angle formula, which is 1 plus the cosine of alpha over 2. I'm going to use the positive version. Pi over 8's in quadrant 1, so I'm going to use the positive version of that. And all I'm going to do is plug in what the cosine of alpha would be, which in this case is pi over 4. So that's the original angle that this is half of. Well, the cosine of pi over 4 is radical 2 over 2. So 1 plus radical 2 over 2 over 2. Again, I would multiply everything by 2. I do not like this denominator here. I don't like fractions inside of my fractions. So I'm going to multiply everything by 2. That'll give me 2 plus radical 2 over 4. And again, in this case, it's my denominator that ended up being a nice perfect square. So I'm going to take the square root of that. The top is still under the radical. It's still not pretty because we have a radical under a radical, but that's what we have. We don't have a radical in the denominator anymore, so there's nothing to rationalize. That would be the answer. Okay? So look at the next one. It says, what is the tangent of 165? And again, they're telling us to use a half angle formula, which means this angle is half of something. If you take 165 and multiply it by 2, what do you get? Well, grab a calculator if you need to. Okay, 165 times 2 would be 330. So this is the alpha angle that this is the half angle of. So what's the half angle formulas for tangent? Again, the one that I like is 1 minus the cosine of alpha over the sine of alpha, where this is our alpha. That's what we're going to do. We're going to do 1 minus the cosine of 330 divided by the sine of 330. And now we're going to use our chart. 330 has a reference angle of 30. It's 30 away from the x-axis. It's in quadrant 4, so I'm going to pay attention to that when I'm doing this next step. Okay, so what do I have? I have 1 minus the cosine of 330. Well, reference angle of 30. Cosine is radical 3 over 2. So radical 3 over 2. Sine of 330. Sine of 30 is 1/2, but it's going to be negative 1/2 because sine is negative in quadrant 4, which is where 330 is. And then what's going to happen? Again, I'm going to multiply everything by 2. I do not like that. I'm going to bring it down here. Okay, I'm going to multiply everything by 2. 2 minus radical 3 over negative 1, which is, just let both of these things be divided by that negative 1. I am going to rewrite this as radical 3 minus 2. Okay? Now, just a little check here. Radical 3 is less than 2. Okay, radical 4 is 2. So radical 3 is like 1.7 something, 1.8 something. Okay, so this number is smaller than that. And if you take that minus that, you're going to get a negative. Well, 165 is in quadrant 2. So if we are taking the tangent of this angle, we should get a negative value. So this checks out. This is the answer to the tangent of 165 using the half angle formulas. Okay, so take a look at your worksheets. Pay attention. Use your formulas. I'm going to give you the formulas, so make sure you have the formulas in front of you as you're practicing the double angle and the half angles. Okay, thanks.